Hello everyone. Today I would like to do a quick test about my 350 watt RF amplifier. So what you see now is the whole testing setup. Let's begin with the signal source. Actually, I use this one, HDMI to BNC signal converter, made in China. You can see I only powered it up, and I don't connect the HDMI signal to it, so it simply what I haven't mentioned is that I converted this one to HDMI to RF, or the cable analog TV signal. This is the output wire. I added another module in this case, so actually it will generate 680 megahertz UHF TV signal, analog TV signal. Since we don't have the picture input, so it simply output the color stripe testing signal through this cable to the preamplifier. Here is the RF power amplifier. You can see the frequency range is between 1 to 1000 megahertz, and the output power is 3.5 watt at the 18 volts input. The negative supply is connected to the case, and the positive connects through this capacitor here into the amplifier, and that's the power LED there. The power supply for the amp is this one here. Next, the amplified driving signal goes through this coax cable to the input stage of the final amplifier. You can see the final amplifier is made up with two BLF 861A RF LED MOSFETs, and what's under this side and that side is are actually coupler 3 dB couplers, like which are showed in these amplifiers. You can see actually some transformer layout, a copper pipe layout. Those are 3 dB minus 3 dB couplers for power divide and power combination. Power combination. Oh, I don't know how to say it exactly in English. Sorry. These two final modules are from a UHF TV transmitter. I tore them down. A water-cooled transmitter, and those two PCBs are from the distributor, which makes the TV transmitters, and this is actually the original preamplifier for driving 4 of these 350 watt amplifiers. Actually, this one will output around 30 to 65 peak the RF signal to drive 4 of these tubes, these PCBs. And let's see the combined RF power under this PCB goes through the SMA connector and through this little the thin coax cable to the directional coupler here, and to our dummy load here. You can see it's actually a 200 watt dummy load, which is designed for let's see, 0 to 3000 megahertz. The VSWR is less than 1.2. simply just a dummy load and the directional coupler configuration. And this is you can see the directional coupler connects to this meter here. Just a standing wave ratio meter. This one here is the forward power and the reflected power. You can actually see they are on different. Now it's the same scale. You can see now the forward power is on 300 watt scale, 4 scale 300 watt here, and this meter here actually is this button is pushed just 10 watt scale here, right? Let's do our test. Oh, this is the 32 volts DC power supply made up with two 12 volt power supply. You can see I modified them just by adjusting the divider resistors on them, so I get a higher output voltage. And this is the main supply for this power supplies. Oh, let's see. Nothing is wrong. Okay. Now let's turn on the power. First of all, you can see if I turn on the power, the amperage just you can see it clearly here. Oh, bad focus. You can see the power actually there is some bias current through the MOSFETs. You can see, right? Just now I didn't turn on this drive amp, and now I slightly turn up the voltage for the driving amp. You can actually see the power is actually going up, right? Okay, 350 watts, 680 megahertz, right? Okay, I turn it down. You can actually notice that the reflected power is so low. You can see we only have 10 watt for scale. So the dummy load is quite good enough. Because of the I need to turn off the power. Because of the poor cooling condition I'm using now, so I can't demonstrate this setup for a very long time. I apologize for it, and this is simply the test. Thanks.